Hi, Algebra 2. Today's topic is in our Applications of Quadratics unit is day 2. We're going to be reviewing how to graph circles and parabolas. And our learning targets are that I can graph a circle, then I can graph a parabola in standard form and vertex form, and number 3, I can predict the number of solutions to a system. So remember from geometry, the equation of a circle is our x minus h squared plus y minus k squared equals r squared. Where h and k are the center of my circle and r is the radius. So notice how it's always equal to r squared. So you'll have to take the square root of this number once it's in standard form to find the radius. So let's start with the first example, and notice how, again, just like when we're used to our vertex form for a parabola, we have a minus inside both equations here. So you'll have to change your signs when you pull them out. So our center for our first example would be 1, negative 2 would be the center of our circle, and our radius would be 3 because r squared is 9, so we take the square root of both sides, and our radius would be plus or minus 3, and because distance is always positive, our radius would be 3. So remembering back from geometry and how to graph them is we first graph this center point. So we put a dot at 1, negative 2, so 1, negative 2, and then we use our radius of 3 units to draw our circle. So from here, we go 3 units in each direction, 1, 2, 3, and then above, 1, 2, 3, and then to the left, 1, 2, 3, and down, 1, 2, 3. Now circles are, some of you are going to be more artistic than others, so just do your best as you draw your circle, and you'll notice you just do your best as you're drawing your circle. Okay, so there's example 1 for how to graph a circle. Number 2, noticed we do not have a k, so the only way you can have a k would be at 0. So notice our center here would be negative 3, that would be our h, and our k would be 0. So our center for number 2 is negative 3, 0, and then our radius squared is 16. So if we take the square root of both sides, our radius could be plus or minus 4, but our radius is always going to be positive because it's a distance, so our radius is 4 units. Okay, go ahead and pause the video and try to graph number 2 and bring it back. Okay, so when you went to graph it, you should have a point at negative 3, 0, and then you would have counted 4 units in each direction and put a dot. Then you do your best to draw a circle. Notice how the smartboard circle is drawn. Very neat. So feel free to, if you want to use a protractor if you're challenged with circles like me. All right, for number 3, I want you to go ahead and try on your own. Notice how they change the order here. So your first step, you need to switch the order to make sure you get the center correct. So notice how they put the y minus 4 squared first. Change the order here with these. Use the commutative property of addition to change the order so that your center is correct. And then go ahead and try to graph it, and then bring the video back. Okay, so remember you should have switched the order first, and your center then would be -3, 4, and your radius would be 2 because your r squared is 4, so if you take the square root of both sides, we would have r is 2. So then you plot your point of -3, 4, 1, 2, 3 to the negative direction, and then +4. And then again, our radius is 2 units. So you plot your other 4 points by counting 2 units from the center, and then you draw your circle. Okay, on the back, go ahead and flip over to the back. We're going to review graphing quadratic equations in standard form. The first step is to remember our axis of symmetry equation, and that's x equals -b/2a. Once you have substitute in those values, you will then take that x value and substitute it for y, and that will give you a vertex. Then you're going to plot points around your quadratic equation from there. So let's go ahead and first solve for the axis of symmetry. So our equation is y equals x squared minus 2x minus 3. A is 1, b is -2, and c is -3. For our axis of symmetry, x equals, we have a -b, so a negative times -2 over 2 times 1. So that would give us 2 over 2, which would equal 1. So our axis of symmetry, remember, is the vertical line that cuts the parabola in half and allows you to use that to plot other points. To find our y value of the vertex, because it's somewhere on this axis of symmetry, we're going to substitute in 1 for x into our equation. So 1 squared minus 2 times 1 minus 3. So 1 squared is 1. And then minus 2 times 1 is -2. And then minus 3 would be equal to -4. So our vertex would be at 1, -4. Our parabola is going up because our a is positive. And our y-intercept is -3. So we can use those points to plot our parabola. So right here would be our vertex, and then -3 is our y-intercept, and I could use the axis of symmetry to reflect that point. Also, I could use the zeros. I could find those to graph some more points. So I could factor that as x minus 3 and x plus 1, and then set each factor equal to 0. We have to find the zeros. So we'd have x minus 3 equals 0 and x plus 1 equals 0. So we have x equals 3 and x equals -1. So those are 2 more points we find the y values at. When the y is 0, we have 3, 0 and -1, 0. So if we plot that, that gives us a nice parabola. Okay. You can also use your graphing calculator to check your work. So you substitute this equation into your TI-83 and use the table to confirm that you plotted your points correctly. When you do that, remember you substitute in your equation into your y 1, so x squared minus 2x minus 3, and you can see your graph by hitting graph. And then to make sure you get really accurate points on your, if you have to graph by hand on the test, you can use your table to find them. So there's our vertex, there's the minimum, we know our parabola goes up. There's the y-intercept and the point we plotted that was symmetric. And here's our 2 zeros. Okay, our other parabola that we learned how to graph was in vertex form. Remember we have h, k, and a. Again, our equation of our quadratic is y equals a times x minus h squared plus k. So for our equation that we're going to be graphing, our h is -1 and our k is 2 and our a is -1 as well. So our vertex would be -1, 2. And then our a is going down because it's negative. Our parabola is going down because our a is -1. So using the parent graph, instead of having the parabola going up and be 1 unit to the left and up, it would be 1 unit to the left and down, and 1 unit to the right and down. Also, we have our points from here would be 1 more unit to the left and now 3 down. 1 more unit to the right and 3 down. So remember, for our vertex form, we can use our knowledge of the parent graph. Remember, the parent graph is the graph that's at the origin, where h and k is 0 and a is 1, so it's going up. Also, you can confirm your graph using the calculator. So go ahead and pause the video and do that. Make sure you know how to use that method to check. So you can see when I substitute in that equation, make sure you use the negative sign on your calculator, and make sure you use parentheses and square what's in the parentheses, and then add k. Also, you see the graph by hitting graph, and you can see the table by hitting second graph, and confirm your points. Okay, the last part for today's video is on the bottom of your page. I want you to think about predicting the number of solutions to a nonlinear system of 2 equations. So anytime you have a system of equations, you're going to be able to kind of make a prediction based on what you know about these equations. So let's say you have a system where you have a parabola with the equation of y equals -x squared minus 3x plus 10, and a line y equals x plus 5. And you can predict the number of solutions. That this one would most likely have 2 solutions, because you can see that you'll have a line with this y-intercept of 5 and a slope of 1, and the parabola is going down. So, and this parabola, the y-intercept of the parabola is above the y-intercept of the line, so that the parabola would open down above it and would give you 2 solutions. So that's how you can use prediction. If you have trouble predicting the number of solutions based on your knowledge of the equations, then you can always graph it. But it is helpful to know both methods. Use your knowledge of your standard form, in this case of the parabola, plus your knowledge of the line. Okay, we'll be practicing more of this in class. I hope you have a great night.